Hi, it's Mr. Barr, and these are the notes for transversals and parallel lines. So by the end of this lesson, you should be able to identify a transversal, identify alternate interior, alternate exterior, vertical, and corresponding angles. Verticals we actually talked about in the last lesson, and determine if angles are congruent. So let's start with the idea of a transversal. So let's start with our name and the title, which is Transversals and Parallel Lines. Transversals and parallel lines. So imagine that I have two parallel lines, boom. Actually, I don't think I could have like a single parallel line. So there are two parallel lines. I have these parallel lines and I take another line and I cut through them. That cutting line right there is called the transversal. So the transversal, it cuts two lines, and when it does, you can see that it actually creates 8 angles. So when that transversal cuts two lines, it creates 8 angles. Now, if the two lines are parallel, we have a whole bunch of congruent angles that are getting created. So a transversal cuts two lines and creates 8 angles. So let's go through the types of angles that are created. Now, I'm going to assume that everything I cut today are parallel. So boom, boom, boom. Everybody on the inside here, so ready? A, B, C, D, E, F, G, H. Okay, you see all those guys on the inside? C, D, E, and F? Those are called interior angles. Angle C, D, E, F are interior. Because they are on the inside. Doing triangles here. Angles A, B, and GH are exterior angles. Which kind of makes sense, right? These are the interior angles, these are the exterior angles. 1 and 3, let's see, so interior. Now, let's get more specific. Alternate interiors, alternate exteriors. So let's start a new piece of paper here. Parallel lines. And I'm assuming everything's parallel for this, although these terms will work for non-parallels also. C and F angle D and E, these are alternate interior angles. So C and F, D and D are alternate meaning on alternate sides of the transversal, interior angles. C and F, D and E, alternate interior angles. We also have alternate exterior angles. Angle A and H, angle B and G, those are alternate exterior. So what do we have? We have transversals, we have alternate interiors, we have alternate exteriors, and now we have corresponding angles. Corresponding angles are angles that are in the same location relative to the transversal and the line. So once again, two parallel lines, a transversal, A, B, C, D, E, F, G, H. A corresponds to E. Angle A and E, A and E. C and G, angle C and G, C and G. Angle B and F, B and F, and D and H. Can't see what I'm writing. So that's an E. It's a sloppy E. Angle A and E, angle C and G, angle B and F, angle D and H. Those are all corresponding angles. A corresponds with E, B corresponds with F. Same position on different lines. Corresponding angles. Same position on different lines. C corresponds to G. It's under the line left of the transversal. B and F. It's above the line right of the transversal. Now, here's the deal. All of these terms work so far, even if the lines aren't parallel, but if the lines are parallel, all those angles become congruent. You know what, before we get too crazy, let's add vertical lines in here, or vertical angles, just in case. Let me see. Okay. Let's add verticals in here before we get crazy. Verticals are not new. We did those in the last lesson. But if we have A, B, C, D, E, F, G, H, A, and D, B and C, E and H, G and F, those are all vertical angles. You know, I don't like the way I wrote that. Vertical angles. Now here's the deal. We already know, and they are congruent. Let's just add that. Which we know means identical in shape and size. If I have two parallel lines cut by a transversal, then a whole bunch of stuff becomes congruent. So if two parallel lines are cut by a transversal. I know, I keep squishing my letters in there. It's because I'm writing with a Sharpie. If two parallel lines are cut by a transversal, then, ready? Then a whole bunch of angles are congruent. Alternate interior, alternate exterior, and corresponding angles are congruent. Alternate interior, alternate exterior, corresponding are all congruent. Assuming it's two parallel lines cut by a transversal. If two parallel lines, and I think the two is redundant, and now I'm walking away, there we go. If two parallel lines are cut by a transversal, then all the corresponding angles and the alternate interiors and all the other angles are congruent, and I'll show you what that means. And the verticals are also congruent, but that's just because they're verticals. So here we go. Ready? All of these angles are super duper congruent. And that's a technical term, super duper, okay. Right, so this angle right here, this angle is congruent to this angle. Why? Because they're corresponding. But look at this. 5 is congruent to 4. Why? Well, because they're alternate interiors. And 4 is congruent to 1 because it's a vertical. And 8, ready? 8 is congruent to 5 because it's vertical, but 8 is congruent to 1 because they're alternate exteriors. So look at all those angles right there are congruent to each other. Now look at angle 2 is congruent to angle 3. Why? Because they're vertical. But angle 2 is congruent to angle 6. Why? Because they're correspondings. And angle 2 is congruent to angle 7. Why? Because they're alternate exteriors. And angle 3 is congruent to angle 6. Why? Because they're alternate interiors. So when I've got two parallel lines cut by a transversal, I actually only have two angles with different measurements, right? I've got the obtuse and the acute. That's it. All right, hey, that's it. I think that's it. That's it. Thanks for watching.